Every year, the United States builds over 40,000 kilometers of new roads, and nearly 30% of them are made with concrete, designed to last 40 to 50 years and carry loads of several dozen tons. But behind these seemingly ordinary roads lies a surprising world of advanced engineering. Road beds are compacted as firmly as skyscraper foundations. Steel reinforcements are placed with centimeter-level precision, and massive concrete paving machines, stretching dozens of meters long, operate like industrial robots right on the construction site. Ever wondered how American engineers turn a pile of raw materials into some of the most durable concrete roads on Earth? Let construction AI show you how. When people think of roads, most immediately picture asphalt. But in the United States, concrete roads are also a common choice. In fact, over 30% of the federal highway system is built using cement concrete. While concrete may not offer the same smooth driving feel as asphalt, it's often preferred for major highways due to its many technical advantages. Concrete roads have a lifespan of up to 34 years, twice that of asphalt roads. They're also less prone to sinking or warping from heat, making them ideal for routes with heavy truck traffic. Concrete also helps speed up construction time, especially when paired with continuous paving machines. With this technology, crews can complete up to 3 to 5 kilometers of concrete roadway in a single day, significantly reducing project timelines. The first step is checking the route and ground conditions. Engineers examine the terrain to understand the strength and quality of the soil and rock underneath, looking for weaknesses, moisture pockets, and load-bearing capacity. This analysis determines how much dirt needs to be removed or added and informs critical decisions about the road's design, how many lanes it should have, how long it will be, and what foundation it needs to support decades of traffic. Once the plan is approved, the construction team clears the area, removing vegetation and obstacles while leveling the roadbed to match the land. The soil foundation must be compacted to support both the concrete pavement and thousands of vehicles using it daily. A grader levels the top layer of soil with surgical precision, while underground systems, electricity lines, water pipes, and drainage networks are installed. Once utilities are finished, the contractor builds the road base, the critical middle layer that transfers weight from the concrete surface down to the soil. A layer of large crushed stone is spread evenly and compacted using a vibratory roller or steel wheel roller. Depending on terrain, expected truck traffic, and weather conditions, this stone layer may be built in multiple levels, a thicker bottom layer for strength and a finer top layer for stability. Heavy rollers continuously move back and forth, increasing load-bearing strength and reducing future settling or cracking. This compaction stage takes 2 to 4 days, depending on the road length and soil moisture. During this process, a water truck drives ahead of the roller to maintain ideal moisture levels. Field technicians closely monitor everything using compaction gauges, vibration sensors, and laser surveying equipment to ensure all measurements stay within tolerances. After the roadbed is fully compacted, the crew moves on to pouring the concrete surface. All concrete is supplied by an industrial batching plant where materials are measured and mixed with near-perfect accuracy. Raw aggregates are transported to the plant and loaded into inline storage silos that keep each type separated: crushed stone, fine sand, and gravel in individual steel or concrete compartments. Each aggregate is weighed using a calibratable belt scale system that measures the exact amount needed for each batch. After weighing, aggregates are dropped into a large capacity feeder bucket. Water is measured precisely and released into the mixer, while chemical admixtures like superplasticizers and accelerators are added through a dedicated dosing system. Once all ingredients are ready, they're loaded into a high-performance concrete mixer, either a pan mixer or twin-shaft mixer, producing a well-blended mixture within a short cycle time. The finished concrete is discharged directly into ready-mix trucks waiting below. These trucks need to move quickly, because concrete can only be used for about 1 to 2 hours before it begins to harden. During transport, the mixing drum keeps rotating continuously to prevent the concrete from separating or setting too early. Once on site, concrete is discharged into the receiving hopper of the paver using a chute or powered conveyor. This requires tight coordination to ensure concrete is supplied evenly and continuously. For long-distance paving, a line of mixer trucks is scheduled in rotation, always one unloading, one arriving, and others queued up. As soon as the concrete is fed in, the slipform paver takes over, automatically spreading it evenly across the prepared subgrade following the exact width, thickness, and elevation specified in the design. The machine is fully equipped with vibrating pans and a slipform mold that compact and shape the concrete while it's still wet. Inside, an auger continuously moves the mix forward, distributing it uniformly before it enters the forming mold. Built-in laser sensors, GPS systems, or 3D guidance technology ensure the final surface stays flat, level, and perfectly aligned. During paving, the machine automatically feeds round steel dowel bars from its storage tray, placing them in the middle of the fresh concrete at mid-depth to help transfer loads between adjacent slabs and reduce cracking at the joints. Thanks to its continuous slip movement, the paver leaves no cold joints between loads, creating a seamless, monolithic slab that's stronger and more durable. Machines like these typically cost anywhere from $120,000 to over $300,000, depending on their size and automation level. With high output and extreme precision, slipform pavers are now the gold standard for building large-scale concrete roads worldwide. Immediately after finishing, a liquid curing compound is sprayed over the entire surface to retain moisture, preventing rapid drying and allowing the material to gain strength gradually. A few hours later, once the concrete begins to harden, workers use special saws to create expansion joints at regular intervals. These joints allow the concrete to expand and contract with temperature changes without cracking. After the joints are cut, workers clean out the dust and debris, then pump in a layer of special sealant, usually polyurethane, silicone, or bitumen. The sealant keeps water, dirt, and other materials from getting into the joints. Without it, water could seep through and damage the base layer underneath. After the entire concrete pouring and initial curing process is complete, workers mark the traffic lanes with yellow paint and place no entry signs to block vehicle access. The road is off limits for at least 7 days while the concrete continues to harden and gain strength. Any premature traffic could damage the surface and compromise the entire project. Finally, site engineers conduct a full inspection and final quality check, including compressive strength tests, surface flatness assessments, and uniformity evaluations. Only after all tests pass is the road officially open to use. It's a methodical, uncompromising process because when you're building infrastructure meant to last decades, there's no room for shortcuts. That brings us to the end of today's video. You've just explored how concrete roads are built in the United States. All information was carefully gathered from various reliable sources, but if you spot anything inaccurate, feel free to leave a comment, and we'll see you in the next video.